So this question is asking us to consider the system of simultaneous equations that's provided here. It's going to step us through basically how to solve it using a matrix method and then using Cramer's rule at the end. So part A here is to write the system as the matrices A, X and B so that we can use the matrix equation essentially to solve it in a moment. So let's go through and do that. So matrix A we know is the matrix of the constants in front of each of our unknowns. So we've already got this in a nice standard form, so it's really just a case of reading them off and popping them in the corresponding row and column. So the first constant here is going to be -1 in front of the x, and then we have +1 in front of y. Here we have a +1 in front of the x and a 2 in front of the y. So that's our matrix A. Matrix B here, that's the one that's on the right hand side, so those solution constants. So we've got -6 on the top and 15 on the bottom. The last thing that we need is our matrix X, and that's the matrix of the unknowns. So our unknowns are X and Y, and we've listed them out in that order, so therefore we need to pop them in the same order in our matrix in order for this equation to hold true. So that there is the answer to part A. So part B, it says find A inverse. So we need the inverse of this matrix here that we've written out. So since this is a 2 by 2 matrix, we have the equation that we can use to find the inverse, rather than having to go through Gaussian elimination, which is quite tedious. So in order to find the inverse, let's start by finding the determinant of our matrix A. Remember, this can't be equal to 0. If it is equal to 0, then we can't find the find the inverse matrix, I should say. All right, so the determinant of this, it's a 2 by 2, so it's AD minus BC. So this is going to end up being -2 minus 1, which is -3. So since that determinant didn't equal 0, that means that an inverse does exist. All right, so let's go and find it. So the inverse is going to be equal to 1 on the determinant that we've just found, and then this is the elements in the matrix. So A and D up here, remember that in the original matrix, it's assuming that it's in this order. So A and D swap over for our inverse, and then the ones on the other diagonal end up with negatives, as we can see here. So we're going to get 1 on our determinant, which was -3, outside of, let me just scroll up. So these are flipping over, so 2 and -1, and then these ones change their sign, so they're both negative now. So let's multiply our constant into the equation, or matrix. So that there becomes our answer for the inverse of a matrix. All right, so part C now is to use our inverse matrix that we've just found in order to get X and Y out. And we're going to be relying on this matrix equation AX equals B. Okay, so we want to get X and Y because that's our matrix of big X here. So rearranging for this big X, if we do a left-hand multiplication of the inverse of A matrix times A times X, we need to do a left-hand multiplication for the right-hand side of the equation as well, so that we keep it equal. We know A inverse times A is equal to the identity matrix. And then the identity matrix times any other matrix, it's just going to end up being that any other matrix that falls out. It's like multiplying a number by 1. It just becomes itself. All right, so this is the equation that we're going to use. So we can fill it in. Our matrix of big X was little xy. Our A inverse matrix was this one here that we just solved for. And our B matrix, we wrote that up the top. It was the -6 and 15. So now we just need to perform the matrix multiplication. So we're going to get -2/3 multiplied by -6 plus the third, times the 15. And then for our second element, we're going to get 1 on 3 times negative 6 plus 1 on 3 times 15. So simplifying this out, 2 times 6 is going to give us 12, and then that gets divided by 3. So overall we're left with 4. And this is going to be 15 divided by 3, so that's 5. Here we've got negative 6 divided by 3, so that's going to leave us with negative 2. And 15 divided by 3, we've got the plus 5. So putting it all together, we end up with 9 and 3 for our answers. So these are like corresponding to the equivalent elements in this other matrix. So the first one, x, is equal to the first one here, 9, and y is equal to 3. So that's our solution to the simultaneous equations. So we've got one little part left here, which was part D. It says show that you can obtain the same answer for x using Cramer's rule. So Cramer's rule, remember, relies on calculating determinants. So let's pop it down here. So the general form of the equation is that xi is equal to the determinant of the matrix AI divided by the determinant of A. And this A matrix is the one that we were just using for the previous steps. So it's asking us to get the use Cramer's rule to get the value for x out. So if we go back to our matrix x here, little x, which is what we're going for, it's a little bit confusing. But anyway, it's the first element in this matrix. So that means that in this equation, we're going to set I to be equal to 1 in order to get x out. So I can rewrite my equation for it. So what this is going to get is the first element in my x matrix, which is little x. So on the top line here, we need to write out our determinant of matrix A, but since we've got a 1 here, what that means is matrix B is going to replace the first column. So if we go back up and look at our matrices that we wrote out initially, so we're going to take this matrix B and put it in the first column of matrix A. Everything else remains the same. This is because we're going for the first element. If we were going for the second one here, then we would take matrix B and put it in the second column. Okay, so we're going for x, so our matrix is going to be negative 6, positive 15 here, and then 1, 2. Okay, and then the determinant of A, that's something that we had already found before, so we may as well recycle it. Previously we said it was equal to negative 3. So now all we need to do is evaluate this determinant. So it's negative 6 by 2 minus 1 by 15. All divided by negative 3. So simplifying, we get negative 12 minus 15 over negative 3. This is going to become negative 27 over negative 3. And then that simplifies to be just 9 on its own. So that's our answer, and hopefully it's the same as what we got from the previous part. And indeed it is. We can see we got x equals 9 here. So that concludes this video, and I'll see you in another one.